Hi everyone. So today I am starting a series of lectures in operating system. So as you can see, this is the first lecture of that series. So the first lecture will be starting with the introduction and motivation. So introduction you all know, in the beginning of every maybe topic we generally try to give some introduction. But coming to this motivation part, why you need motivation and why I decided to put this motivation kind of thing. I'll explain you. There are two subjects. One is operating system, another one is computer organization and architecture. So these two subjects are very much scoring, and the downside is you will have to remember multiple concepts. Okay, so when you are writing your paper, it will be very much difficult for you to remember all those things in OS and COA. Okay, but the good side, as I said, this is the most scoring subject. Okay, so the purpose of motivation is whatever electronic gadget you are using, it might be your laptop, it might be your iPad, it might be your mobile phone or your smartwatch, whatever you are using, my expectation is after learning operating system and computer organization and architecture, you should be able to relate whatever you are seeing over there and whatever you are doing in your gadget. You should be able to relate those things, okay, end to end. So the moment you start relating your real world things with the concepts that you are learning in OS and COA, so as a result, you will end up falling in love with operating system and COA. Okay. So the moment you are in love with OS and COA, all those points that I just told that you will have to remember, it will be very much easier for you to remember all of those things. Okay. So as a result, you will be super good in OS and COA and you will be scoring as much marks as possible. So whether you are going for your GATE exam or any other competitive exam or maybe your semester exam as well. Okay. So this is the purpose of motivation. Don't get bored. So initially, few terms you may not be I mean for first few terms you may think okay you are not familiar to this term. That is fine. That is absolutely fine. Keep on watching the videos. After few videos, all of those points will start making senses. Okay. So wherever possible, whatever topic I will be explaining in COA and OS, this is a series of OS. So whatever topic I will be discussing, I will try to relate those topic with your daily gadget that you are using. Okay. So now let's start the lecture. Fine. First thing, whatever application you are using that talks to OS on your behalf. Okay. First question is, why do you need operating system? Maybe first question might be, what is operating system? I will come to this later. First, I will address the question, that is, why we need operating system? Okay, why? Why? The reason is, whatever application an user uses, that talks to hardware through the operating system. So let's say you are using Facebook or you are using YouTube. So let's assume you have clicked on a music, okay, music video. What is your expectation? Your expectation will be, in the screen you should be able to, let's say this is a YouTube, in the screen you should be able to see the video, okay, and there are speakers, you are expecting some sound from there. Okay, so this is the expectation. So expectation is coming to, let's say this is a YouTube, okay, this is a video, just I give this example, and this is the audio. Okay, so this is the result, expectation. Fine. So this is the YouTube app. Okay, so the moment you are clicking on a music video, how your screen knows which video to play, what to do, how your audio ports know what to play. Okay, so whenever user talks to the application, let's say for this application, for this example, let's say you are the user, you have clicked on a video, music video on YouTube. So YouTube is the one to whom you are talking to. Okay, YouTube on your behalf will talk to operating system. What YouTube will say, hey operating system, this user wants to play this video, and simultaneously this user wants this audio to be played. Okay, so whatever user is doing, the end goal is to see the result, and to see the result, open this user talks to app talks to OS, and via this OS you can see the result through the hardware. Okay, like you can see the video, you can listen music. Okay, so operating system is the, you can say operating system is an interface between user and hardware. Okay, So the moment if I say you operating system is an interface between user and hardware, you may forget this. But the moment I have given you the example from YouTube, how your YouTube is, how your YouTube is successfully playing the video and playing the audio by talking to the operating system. So that is the purpose of operating system. So coming back to the question, why operating system? So if let's say assume for a second there is no operating system, your app will not be able to talk to the hardware. As a result, what will happen? You will not be able to see the result in the hardware. It might be on, you are seeing something on screen, or you are listening some audio from the sound ports, something like this. Okay. So whatever gadget you have, all of them have, all of them are having OS inside, because if just I said, if OS is not there, you will not be able to see the end result of your actions, okay, of your expectations. So OS is the one who is, let's say your application is a human, and this what do you call this operating system is a heart. Okay, so let's say there is a human body but there is no heart. What is that? Something like this. Okay, so as a single line, operating system is the heart of your all the electronic gadgets. Okay, that is what and why. Both of these things I have answered. Okay, this what thing I will answer in more theoretical way. Okay, so what thing I have answered in conceptual way, now I will answer in theoretical way. So I have told this OS is interface between user and hardware. Okay, then comes what is operating system. Operating system you can say is a resource allocator and resource manager. Okay, so what is resource? From operating system point of view, okay, from operating system point of view, there are multiple kind of resources possible. One might be your monitor, one might be your keyboard, okay, maybe your printer, these things. These things, whatever hardware you can see as of now, consider those are resources. Okay, so operating system knows that there might be multiple processes running simultaneously, and multiple processes may ask for monitor, but operating system decides to which process this monitor has to be given. Okay, so that is why this is called resource allocator. Okay, operating system is the one who allocates resource to a particular process and deallocates resource from a particular process. Okay, let's say just an example, let's say you are playing a video game. Okay, your screen resource is given to this video game process. Okay, let's say you are playing a video game and this is your screen, video game is playing there. So this screen resource is given to video game process. Let's say your mother is calling you. Okay, now this video game will be replaced by the incoming call screen. What is happening? Due to the higher priority, your operating system, what your operating system is doing? Your operating system is deallocating the screen from your video game and allocating the screen to the calling app. Okay, so this is resource allocator. And what is resource manager? Resource manager says why this is resource manager. We are calling it resource manager. Why so? Because operating system is the one who is allocating resources to the processes, okay, and deallocating as well. So operating system should be knowing all the states of the resources and corresponding processes. Okay, which process is holding which process, which resource, and let's say there is a process for how much time this process is keeping this resource with him, and those things. Okay, so the moment OS is the one responsible, OS responsible for allocating. Okay, the moment OS is getting responsible for allocating, in the same moment OS is getting responsible for the managing of the resources as well. Okay, that is why OS is called resource allocator and resource manager. So what is done, why this is also done, fine. Okay, now next part. So user, let's say I'll come back to this part. User cannot directly talk to hardware. User as in application. This cannot talk to directly hardware. It is because let's say you are an user. Okay, user gives instruction. You are giving instruction to your computer. Can it understand you? This hardware part, can it understand you? Your instruction. The answer will be no. Let's say you are saying, hey printer, go and print this PDF. Printer doesn't understand. Okay, printer says, I don't understand you. What you are saying? So now operating system comes. Operating system understands what you are saying. So when you are saying, hey printer, go and make this print of this PDF, operating system understands what you are saying. Okay. Now operating system on your behalf talk to the printer. You, this is operating system. Okay. There is printer. Okay. So on your behalf, operating system talks to the printer. Hey printer, the user wants you to print this PDF. Go and print. Now printer understands, oh, I need to print this PDF. Now printer goes and print this PDF. Okay. Example, let's say you are writing printf something, let's say hello world. Okay. How monitor prints that? We don't care. OS is there to handle everything. Okay. Let's say this printf function, there might be multiple things inside hardware level that we are not worried about. How a printf statement is getting printed in the monitor. Do we care? No, we never care. So if we start caring about those things, there are so many other things as well that we will not be able to take care of those things. Okay, let's say complexity of the code, maybe space complexity, time complexity. Those are things. Those are the things where a programmer will think of. But this software to hardware interaction, okay, from you, I mean this user or application to hardware interaction, these interactions we are not supposed to think of. Okay, operating system is there. Operating system takes care of everything. We just say printf hello world. Operating system knows what you are saying. Operating system knows how this message has to be sent to monitor, and that is how operating system sends this message. User wants you to print hello world. Now this monitor goes and prints the hello world. Okay, this is just an example about the printf. Okay, so there might be if printf, like maybe you are trying to write some file. Okay, so there you will be using if printf. Okay, they are also the same thing. You are not worried about how bytes are getting read from the file. Fine, you are just asking if printf and this is getting read, something like this. So there are multiple type of operating systems. So here I'll be discussing the top, I mean, four most popular kind of operating system. First one is batch operating system. What is batch operating system? So jobs executed in batches without user interaction. What is that? Let's say if you know supercomputer, let's say this is a supercomputer. Okay, there are multiple people, they are putting their jobs like this. Okay, in a queue kind of thing. So computer what does? Computer takes this process, results the output and stores the output somewhere. Then takes this job, stores the output somewhere. Then again takes this job, stores the output somewhere. Something like this. There is no user interaction. Okay. So mostly in supercomputer you can see batch choice kind of thing. Then comes multi-programming. What is multi-programming? Multi-programming in a single line, it name suggests the meaning, that is multiple programs stay in the RAM. Okay, it's not like only one program is in the RAM. There will be simultaneously, there will be multiple number of programs residing on the RAM. Okay, then there comes multitasking. What is multitasking? Multitasking says your CPU will switch between multiple processes very rapidly. Okay, let's say there is a CPU, it is working on process 1. Let's say process 1 will be taking, let's just an example, 10 minutes. Okay, after 1 minute process 1 is getting pulled out from CPU and process 2 is getting assigned. Okay, after few maybe after 2 more minutes, this process 2 is getting pulled out and process 3 is getting pulled into CPU. Something like this. Very rapidly these switches take place. Okay, this is multitasking. Okay, so this the moment I am saying, there is CPU, there is process P1 is going, we are pulling out P1 and we are pushing P2. So this pulling out one process and pushing back one more process is called context switch. Okay, so as of now just know the name context switch. Later we will be seeing more detail on context switch. Okay, so fine, this is multitasking, we are done. Then comes multiprocessing. Multiprocessing says in a computer there will be multiple number of CPUs, like octa-core, quad-core. Octa-core means 4 CPUs, 8 CPUs, or quad-core means 8 CPUs. Okay, something like this. This is multiprocessing. So when you have only one CPU, what happens? At a single time, let's say this is one CPU. At a single time, you can assign only one process. Let's say process 1 is assigned. So if process 2 comes, you will have to pull this process 1 back from CPU. Okay, then only you will be able to push process P2. This is the disadvantage in only one core on one CPU. Let's say there are CPU 1 and CPU 2. process 1 came, you assign to this thing, then process 2 came. Now you don't have to pull P1 back from CPU 1 because you have CPU 2 which is sitting idle. You push P2 to CPU 2. Fine. That is how you do execute these parallel executions. Okay. So this is multiprocessing. There will be multiple number of CPUs. Fine. Now one more concept. There is something called system call and there is something called function call. Okay. So what is function call? So when you are writing a code, whatever function call you are making, okay, from one function to another function, all of them are function call. If I take some real world example, let's say you are writing printf, okay, in your C code, in a, let's say some hello.c file, let's say there is a hello.c file, over there you have written this line printf. What you have done? You have called a function where this function is present in the C library is present, okay. Whoever has written the C library, he has written the definition of printf, okay. Fine. What it does is your monitor or maybe any hardware, okay, monitor or screen, whatever, they have not given permission to this C library, okay. This C library you have definition of printf. What it does is it makes a system call to the kernel. What is kernel? Kernel is the code of operating system, okay. Just like a code of a human is the heart, human is heart, your device is OS, something like this, okay. This is the code of operating system. This is called kernel. So what happens is C library from the definition of printf, it directly calls to the kernel and says, hey kernel, you take care of this problem that I am asked to do. And what is that? The user wants me to print something. Fine. This call is called system call. Fine. Now kernel talks to screen driver and screen driver talks to screen, and you can see whatever you have written, maybe hello world or something, you can see hello world here. Fine. So this is function call. Fine. This is system call. Okay. And this is the difference between function call. Function call is at the user level. This is at the user level. This system call is from user to kernel. Okay. Fine. Na? C library is written by user. This is also this is present in user level only. That's why printf is user level. This is also user level. But kernel is not user level. So function call is user level to user level, and this system call is user level to kernel level. Okay. Something like this. Two more important things. One is OS, another one is COA. So to see the end-to-end kind of thing, let's say 2 plus 3 equal to 5. That you want computer to calculate 2 plus 3. Fine. So you need to see the end-to-end picture. So you need OS and COA both. OS talks on the software design aspect of your computer. COA talks on the hardware design aspect of the computer. Now you are learning operating system. After this you will learn computer organization and architecture. So that the moment you have learned both of these two things, I will help you to connect this line, so that you get to see how 2 plus 3 equal to 5, how this thing is getting calculated inside your computer, and for every instruction how these instructions are getting executed end to end from user level to hardware level. Okay, so you will understand end to end how a program is executed from user to hardware. So again, in first few videos you will see many terms, all of them may not make sense immediately, but going forward you will understand everything. Just keep on watching the videos.